In this video, we're going to learn the derivatives of the logarithmic function. So in order to do that, we're going to use their relationship to exponential functions to find their derivatives. So I just want to remind you, because we're going to be using it quite a lot today, that f of x is equal to log base a of x is the same thing or equivalent to a to the f of x is equal to x. Okay, and then when this is base e, so a special case of this, so if f is ln x, that means that e to the f of x is equal to x. Okay, so we can use our knowledge of the derivatives for the exponentials in addition to the chain rule, because we're going to have a function in the exponent. And this can help us to find the derivative of ln x and log a of x. So we're going to start with the e version. Okay, so what we want to do is we're going to take this equation, okay, and we're going to differentiate both sides. So if these are equal, then the derivatives of each side should also be equal. Okay, so d by dx of e to the f of x should be equal to d by dx of just x. Okay, so now the right-hand side is easier to differentiate. It's just 1. What about the left-hand side? So we have e to a box. Okay, so the derivative of e to something is always e to the same thing. So it's going to be e to the box, so e to the f of x, but then we have to multiply by the derivative of the box. So that's going to be f prime of x, and that should be equal to 1. So this is the outer derivative, okay, and this is the inner derivative for our chain rule. Okay, and that should be equal to 1. Now what we want is actually the derivative of f prime, or f, sorry, we want the derivative of f, right, because we're trying to find the derivative for ln x. So what we can do is rearrange this equation. Okay, so f prime of x should be equal to 1 over e to the f of x. Okay, now e to the f of x, okay, we know what this is as well because it's just x. Okay, so we can actually replace this, so f prime of x is just 1 over x. Okay, that's actually the derivative for the natural log. So if f of x is ln x, then the derivative is 1 over x. So written all at once, the derivative of ln x is 1 over x. Okay, now we can do the same thing for other bases. Okay, so we want to differentiate both sides of this equation. Okay, so we're going to have d by dx a to the f of x equals d by dx of x. Now the derivative for a of x is just a little more complicated. Okay, it's the same, a to the box, but then we have this ln a as well. Okay, so this part is the outer derivative, and this part is still the inner derivative, because that's our exponent, that's our inside function. And now we solve for f of x, or sorry, f prime of x. So it's going to be 1 over a to the f of x times ln a. And again, a to the f of x is equal to x. So our derivative is 1 over x, but times ln a. We still get this extra ln a factor, just in the denominator this time. So the derivative of log a of x is 1 over x times ln a. Okay, or all at once, d by dx of log base a of x is 1 over x times ln a. So let's do some examples. So what if I want these derivatives? So here I have y is log base 3 of x. Okay, well this is just applying the rule directly. So y prime is going to be 1 over x times ln 3. Okay, so that's just applying the rule directly. Okay, here we're using the chain rule. So we have our inside function, which is 3x. Okay, so when we take the derivative, f prime of x is going to be 1 over my box. Okay, so that's 3x multiplied by the derivative of the box. Okay, so that ends up being 1 over 3x times 3, which is 3 over 3x, which is actually still 1 over x. Okay, so maybe I'll just write a little note here. So in fact, if you ever have ln of a number times x, the derivative is always just 1 over x, because you're going to multiply by the derivative of the inside, which is going to be k, and they're going to cancel out. Okay, let's try another one. So here I have a 2, log base 2, but also the chain rule. Okay, so this is my inside function. So g prime of x is going to be 1 over my x, which is my 8x cubed, times ln 2, but then I have to multiply by the derivative of the inside. Okay, so this is going to be 1 over 8x cubed ln 2 times 24x squared. And now we can cancel. So the 8 is going to turn that into a 3, and the x squared can cancel with 2 of those. So I'm going to get 3 over x ln 2 as my final derivative. Okay, so putting this together, we can write the rules a bit more generally. So if you have ln of g of x, so you have this sort of inside function, what it's going to be is 1 over g of x, because that's the rule for ln, that's the outer derivative. But then you're going to have to times by the inner derivative, which is g prime of x, which you could just write as g prime of x over g of x. Okay, if it's a base a, same idea, but it's going to be 1 over g of x times ln a. You're just going to get that extra ln a factor. So it's going to be g prime of x over g of x times ln a. Now, when you have these absolute values in here, you actually get the exact same derivatives. So you actually get 1 over x for ln and 1 over x ln a. So the absolute value does not affect the derivative. For the log values, so all it does, so other than making the function valid for more x values. Okay, so you get the domain will now be negative infinity to 0 and then 0 to infinity, so everywhere except 0, instead of just the positive side, 0 to infinity. Okay, so if we take one of these, I'll just draw you a quick sketch. Okay, it looks just like the log graph on this side. Okay, so you get something like this, but then you get the same thing on this side, but just going the other way. Okay, so that's for either of these. Okay, they both look like that. So the slopes are the same, but they're going to be negative, right? But x is negative on that side. So 1 over x is going to be a negative number. So it works out nicely. So you don't have to stress about the absolute values if they're inside a log when you're taking the derivative. Okay, couple more examples. Okay, using these rules. So if I want the derivative of ln of this polynomial, okay, this is my inner function. Okay, so the derivative, because it's ln, is, okay, well, I'm going to do 1 over the inside, okay, times the derivative of the inside, which you could put together as the derivative of the inside over the inside. Okay. Now, what about log base 2 of square root 3x minus 2? Okay, well, this is going to be, so I have this inside bit, so it's 1 over the inside bit, okay, times by ln 2 because of the log base 2, and then I need to times by the derivative of the inside bit. Okay, now this thing is actually 3x minus 2 to the power 1/2. Okay, so to take that derivative, we bring the 1/2 down, and then it's 3x minus 2 to the power negative 1/2, and then we multiply by the derivative of the inside, which is 3. So we're using the chain rule again. Okay, so now I'm going to just rearrange. In fact, let me just move up because I'm going to need a couple steps here. I'm going to rearrange this inside the brackets here. So I have initially 3x minus 2 in the square root ln 2 times 3 over 2 square root 3x minus 2. Okay, now putting these together, the square root's going to go away because I have 2 of them. So I'm going to get 3 over 2 ln 2 times 3x minus 2. Okay, now we could have actually done this in an easier way. I'm going to do it up here. So we could have simplified first. So this is log base 2 of 3x minus 2 to the power 1/2. So I could have brought the 1/2 down to the front. Okay, now this is easier to take the derivative of. So the 1/2 just stays out front, and then it's going to be 1 over the inside bit times ln 2 times the derivative of the inside bit, which is 3. So putting that together, we get 3 over 2 ln 2, 3x minus 2. Get the same answer, okay, but much faster. So it's normally a good idea to simplify, and the log rules can be very useful. Okay, so let's try another one. Now C and D look very similar, but their answers are actually very different. Okay, so here I have a multiple chain rule. Okay, so the ln of the absolute value x squared plus x is all inside the 3. So that I could let be u. On x, okay, then y is u cubed. Okay, so when we're taking the derivative, y prime, it's going to be 3u squared, so the derivative of u cubed, times the derivative of u, okay, which is going to be 1 over x squared plus x times 2x plus 1. Okay, so this part is dy du, and this part is du dx. Okay, and then we just need to replace with u, so this is going to be 3 ln absolute value x squared plus x all squared times 2x plus 1 over x squared plus 1. Okay, so that's what our derivative will look like. Okay, now for the next one, the cube is just on the x squared plus x, the absolute value. So that means that we can actually bring it to the front using the log rule. So this is 3 ln of x squared plus x. So that means that y prime is going to be 3 times, and in fact the derivative we just did. So this is going to be 2x plus 1 over x squared plus x. So they're very different, okay, and it's the brackets, okay, so the 3 in part C is on it's on the ln as well, whereas this 3 is just on the inside of the ln, okay, so that behaves very differently. So just 2 more. So here we are combining some rules now. So I'm going to use the well, I could use the quotient rule or the product rule, okay? So it's possible that you could rewrite this as ln of 5x times e to the negative 3x squared. Okay, if you want to use the product rule. Okay, or we can use the quotient rule like it's written now. So I'm going to use the quotient rule. Okay, so y prime is going to be the derivative of the top, okay, times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Okay, so now I just want to compute these derivatives. So the derivative of ln of 5x is actually just 1 over x, but it's 5 over 5x if you want to use the regular rule, times e to the 3x squared. Now the derivative of e to the 3x squared is going to be e to the 3x squared times 6x, and then that's also times ln 5x, and this is all over e to the 3x squared. I can factor out an e to the 3x squared. Okay, so I'm just left with 1 over x, and then 6x ln of 5x, all over e to the 3x squared, all squared. Okay, now I can cancel one of those. So I just have 1 over x minus 6x ln of 5x over e to the 3x squared. Now we don't really like fractions within fractions, so what I'm going to do is just multiply the top and the bottom by x. Okay, so I multiplied by 1. The x on the top has to go to both terms. I didn't quite make that arrow far enough, but you get the idea. So it's going to be 1 minus 6x squared ln of 5x over x e to the 3x squared. Okay, that's how I'd want to leave my derivative. Okay, now one more. This one looks ugly. Okay, so it's ln of all of this stuff. Okay, so if we were to compute this right now without doing anything, just plug and chug, what we're going to have to do, maybe I'll write this a bit. So y prime would be, I'm going to call it 1 over the mess, okay, that whole thing. Maybe let me just highlight it. Okay, so all of that is the mess, okay? And then I'm going to have to times by the derivative of that mess. Okay, the derivative of that mess is going to involve the quotient rule and the chain rule on the top and the bottom. Okay, that is going to be ugly. We definitely don't want to do it that way. Okay, I don't want to do it that way. So what I want to do is simplify first. Okay, so y, so I can use the log rules. So y I can write as ln of the top minus ln of the bottom. Actually, do you know, I could have actually canceled an x first. So let's do that. So this x is gone, and this x is going to be a square. Okay, that's going to make things just slightly less complicated. Okay, now I have a product inside, so I can break them all up. So here in the first one, I actually have 5 times x squared times the square root. So that's going to be 3 parts. So this is going to be ln of 5 plus ln of x squared plus ln of 3x plus 1 to the 1/2. So I rewrote that as to the power 1/2. Okay, and then in this side I have 2 times this other thing. Oops. So it's going to be ln of 2 plus ln of x minus 1 to the power 5. Now these brackets are important, okay, because I need to subtract both of those things. So the rule for multiplication is to put a plus in between, but the minus out front of the whole thing is going to make them both minus. So I'm going to do that, but I'm also going to bring these powers down. Okay, so they're on everything that's inside the ln, so they can all come down. So this is going to be ln 5 plus 2 ln x plus 1/2 ln of 3x plus 1 minus ln 2 minus 5 ln of x minus 1. Okay, so that's as simplified as we can get. Now, y prime is going to be the derivative of each part. Okay, the derivative of ln 5 is a number. Okay, so that one's a constant. This one is also a constant. Okay, so there's 0. 2 times the derivative of ln x. Okay, that's 1 over x. 1/2 times the derivative of ln of 3x plus 1. So it's going to be 3 over 3x plus 1. So the derivative of the inside divided by the inside. Ln of 2 is 0. And ln of x minus 1 is going to be 1 over x minus 1. Okay, so this is actually 2 over x plus 3 over 2 times 3x plus 1 minus 5 over x minus 1. Okay, this is how we could leave our derivative. And notice that we did not need to use the chain rule with the quotient rule, with the product rule, with all the rules put together. Okay, all we used was the log rules. Okay, to simplify, we used all the log rules. Okay, that they're not hard. All we did was split up anything that's multiplying inside and dividing, and then all the powers that we could move down, we did. Once we do that, all we need is the chain rule and the derivative rule for log. Okay, so this is a much better way to do it.